Good afternoon. In today's session, we have to study about the numericals on the mesh analysis. So, mesh is nothing but it is also a loop. It is a loop. We are using mesh analysis to find the value of current by using the KVL. It means what? If we are supposed to use mesh analysis, at that time we can use KVL to find the value of unknown current. And if in any circuit the value of current is known, it means what? The given current is having known value. At that time we are calling that mesh as a super mesh. And if there is a known value of current and we are supposed to find that value of current by using the mesh analysis method, at that time we are saying that as a mesh, or we are saying that loop, that circuit as a loop circuit. So here, if we are having a network which will consist of many energy sources, which is having many energy sources and the impedances. You can see here we are having two voltage sources, we are having three resistances here. So what we are saying, if in any given network which consists of many energy sources, impedance, then KVL and KCL are not enough to analyze the circuit, at that time we can use mesh analysis method to find the value of unknown current. Since this analysis make use of KVL, this method is also called as a KVL analysis. So if we are considering this circuit, we are we can apply KVL for each loop in terms of current, because here we are supposed to find the value of unknown current. जैसे हमने नोड एनालिसिस में KCL अप्लाई किया था, बट वहां पे हमने जो इक्वेशंस लिखे थे वो इन टर्म्स ऑफ voltage लिखे थे, because at that time we were supposed to derive the value of unknown voltage for each node, but here we are supposed to find the value of unknown current. So here we can apply the KVL and we can write equation of KVL in the form of current. So here we will get the value of unknown current. So if we are considering fixed our sign convention, it means what? We are considering voltage rise as a negative and voltage drop as a positive. At that time, if we are applying here KVL for loop 1, you can see here, if we are taking the positive directions, if we are taking here clockwise direction and we are applying KVL, so you can see here we are considering from clockwise, but here voltage is from negative to positive, so we can take minus Vs plus, here it will be positive, it will be negative, so you can take plus R1 into I1. Now you can see for this R3, I1 is going clockwise, but I2 is going outgoing. It means what? If you see I1 for this R3, it will outgoing, so you can take it is as a positive, and I2 is incoming, so you can take as a negative. So here you can take I1 minus I2 into R3 equal to 0. So here, if you are applying again KVL to this second loop, now we can apply KVL to the second loop. In our second loop, what we are getting here? Sneha Asnevar, you have not joined our previous session. Why? Are you there? Sneha Asnevar. Okay. You guys are supposed to join this class because we are solving the numericals. Okay. You can see here. Now, when we are applying KVL to this loop, how we can apply? KVL क्या बोलता है? Algebraic summation of voltage for each loop will be 0. So, we can calculate voltage for this, and voltage for this. If we are taking here clockwise directions, how we can calculate? R2 and current flowing through this R2 will be I2. We can take it is positive because it is potential drop. Again, if you are calculating this, you can see here. Here we are having the value R1 IS. So we can take R1 and that value as I1 minus I2. Again, if you are calculating, or you can write here R1 into IS, because they have given here IS. But we are considering here IS equal to I1 minus I2 because they have given. That's why I have written here R1 into I1 minus I2. This is the small R1 they have given here. But now, if you see for this R3, we can see here I2 is outgoing if we are taking the clockwise direction. And if we are considering from this point. But I1 is incoming. So we can take I2 as positive and I1 as negative. So the voltage across R3 will become R3 into I2 minus I1. So here that will equate summation with respect to 0 because according to KVL, algebraic summation for voltage across closed loop will be 0. Now, if we are solving these equations in terms of I1 and I2, we can compute other quantities of our interest, branch voltage, branch current, and we will get our equation in the form of linear. So here, if we are considering a circuit which will consist of, here we have finished about the mesh analysis. What we are saying, now we can solve this the linear equations. तो तुम्हें मैट्रिक्स में सॉल्व करना है और तुम डायरेक्टली लीनियर इक्वेशन सॉल्व कर सकते हो. यू कैन सॉल्व बाय एनी मेथड, यू विल गेट द थिंग्स. Now we are supposed to study about the superposition or the linearity. So we are saying a network as a linear network. If a circuit will consist of independent sources, dependent sources, and resistor is linear. That is means what? If we are having the equations of system that are describing the circuit in linear form, we are saying that network as a linear. So here the dependent sources, dependent means VC, VS, CV, CS, like this, voltage dependent or the current dependent, and how they are depending on which they are depending on voltage, they are depending on current. We are having the four dependent energy sources just we have seen in our previous session. So here, if the dependent sources are assumed to be linear, if we have CCVS, it means what? Current controlled voltage source with voltage equal to A and B are the constant. If we are having the equation like A I square plus B, the resulting system will no longer be linear. It means what? If we are having the system which will be linear at that time also, at that time only, we can apply the principle of superposition theorem. So in the context of the circuit, superposition enable us to consider independent sources one at a time and compute the desired quantity of interest in each case and get the result by adding the individual contribution. Or in simple manner, you can say about the superposition theorem, like superposition theorem will consider only one energy source active at a time, and it will consider remaining energy source. If there is a voltage source, it will consider it is as a open source, and if there is a current source, it will consider as a short circuit. So we can say about the superposition theorem like it is valid for the circuit with linear impedance. It is not applicable to the circuit which will contain at least one or more non-linear elements, because here in the superposition theorem we will require only the linear elements. So superposition theorem can be used in a network supplied by generator with several different frequencies to compute the values of current, because it will give us the sum of individual currents to each frequency. So about superposition theorem, we can say like superposition theorem is used to find the value of voltage across any branch in a circuit which will consist of impedance and more than one independent energy sources. because by using the linear superposition theorem, we are considering only one energy source active at a time. So in a linear circuit containing linear and a bilateral element and energy sources, voltage across any branch or current, it's given by algebraic sum of voltage or current due to each energy sources considered individually. So here we can say we cannot apply superposition theorem to the dependent sources because we can apply superposition theorem only to linear circuit and to the independent energy sources. So what about the statement we can say? We can use only one energy source at a time and we will consider remaining energy source deactivated. We are calculating the value of voltage because of only one energy source, and then we are taking the algebraic summation of that voltage to find the value of voltage by using the superposition theorem. So we can say superposition theorem refers to superposition of response due to independent sources. We can consider one independent source at a time and we can deactivate all remaining independent energy sources by using the superposition theorem. Saurabh Deshmukh, you have also not joined our previous session. Okay. So what we are doing here in superposition theorem, we are considering only one energy source active and we are considering all remaining energy sources as a deactive. So if we are deactivating the current source, we can take that current as a 0 volt and we can consider current source with the open circuit, because we know in open circuit current will be 0 ampere, and if there is a voltage source we can consider as a short circuit, because we know if there is a short circuit the voltage will be 0. So we can deactivate if there are many voltage source, we can deactivate all voltage sources only considering only one voltage source active. So if we are considering deactivate, so we can consider this voltage source as a short circuit, because in short circuit voltage across short circuit will be 0 volt. If we are having this circuit and if we are supposed to use superposition theorem, can anyone tell me how many energy sources are there in this circuit? Please answer the question. Anyone? Okay, you can see here there is a one voltage source and there is a one current source. So what we are supposed to do here, we are supposed to use the superposition. So how we can use superposition here? If we are considering only one energy source, if we are considering supply voltage and deactivating current, how we can deactivate? We can deactivate current by making its open source. तो मैंने open कर लिया है. So if you are calculating here current by using these two resistors, we know these are in series. If we are considering it is a open, these are in series, so 4 plus 2 will be 6. So now we can apply here Ohm's law. V equal to IR. We are having the value of V, we are having the value of resistor, so we can convert our equation in the form of I. So I1 equal to V by R. V is nothing but 18 and resistance, total resistance is 4 plus 2, 6. 18 by 6 you will get 3 ampere. 6 tries 18, so you will get here 3 ampere. Now, if we are considering I2 as source and if we are considering Vs as a energy source, here we are supposed to give one slipping line. Here you are supposed to give one slipping line. It will be the closed circuit. Here only we are considering this as a short circuit. So our circuit will become like this only, but here only wire. As it is, यही circuit रहेगा यहाँ पे, but यहाँ पे wire रहेगा. So what will happen here? We are supposed to find the value of I2 flowing through this 2 ohm. How will you calculate? We are having the total current. This is flowing through the 4 ohm. So we can take 3 ampere. We can use the current divider rule. We are supposed to use this circuit. We are considering here wire. We know value of I1 is 3 ampere. If we are calculating the value of I2, we can calculate as total current that will be 3 ampere into the resistors that will be in parallel with this. So we can take ये I1 कैलकुलेट कर रहे हो तुम फिर से because we are supposed to use superposition and then we will take the summation. So if you are calculating, this is the I11. Now we can say it is the I12. So if you are calculating, you are having full current, total current as a 3 ampere. We are supposed to find the value of current flowing through this 4 ohm. 4 ohm. We know 2 ohm is in parallel with 4 ohm. So you can take 2 ohm in numerator upon total resistance. 2 plus 4 into total current, that will be 3 ampere. So 3 into 2 upon 6. 6 upon 6, you will get 1 ampere. So now you are getting I11 equal to 3 ampere, I12 equal to 1 ampere. So you can take total current flowing through 4 ohm as a summation of I11 plus I12, that will be 3 ampere plus 1 ampere. So you will get as a 4 ampere. So here we have seen about the superposition. If we are having any circuit, we can consider only one energy source active at a time, and we can consider other energy source as deactive. We are considering here current source as a open circuit. If we are considering current source active, and if we are not considering voltage source active, if we are considering it is deactive, we can make here wire. So you will get 2 ohm, 4 ohm and here 3 ampere current. So you will get here value of current that will be equal to I12 equal to the resistance that is in parallel with 4 ohm. You can take 2 ohm. 2 upon total resistance 2 plus 4 into total current 3 ampere. You will get 1 ampere, and if you will take summations, you will get 3 plus 1 as a 4 ampere. Now if we are having this circuit. So here you can see we are having the three energy sources. One, two, three. We can consider one by one. If we are considering one, this, we can make this as a wire. इसको wire बना देंगे, इसको open करेंगे. So you will get circuit as 1 ohm, 12 volt and 3 ohm. You can see here. When we are considering this only 12 volt, if you are considering this 12 volt, so you can make this as a open circuit and you can make it is as a wire. So you will get equations. When you will apply, you will get minus 12 because it is from negative to positive, plus 3 into I, plus 2 into I, plus I, that will be equal to 0 because here is a 1. So 1 into I equal to 0. So you will get I equal to 12 minus 12 plus 5 plus 1. So minus 12 plus 6. You will get minus 6. So you will get I equal to, here if you calculate, you will get I equal to 2 ampere. Because if you see, you will get 3I plus 2I plus I, that will be 6. So minus 12 equal to minus 6I. So you will get I equal to 12 by 6, that will be 2 ampere. And now when we are considering value of IS as active, if we are considering this 6 ampere as active and if you are making this 12 volt deactive, so your equation will become like, you can see here. Now when we are considering this voltage, if you are applying KVL, 1 into I plus 6 plus I, because they have given here. So we can take 6 plus I into 3 plus 2I, because they have given here 2I. So you can take as it is 2I, and this will be 3 into I you can take, and you can take directly as 6. So you will get I equal to minus 3 ampere. If you are calculating here voltage, you will get 6 voltage, and if you are calculating voltage here, you will get I into R. R is having 3 and R is nothing but we are having value of R is 3 and current is 6. प्लस -3 बिकॉज वी आर हैविंग हियर -3. यहाँ से जो करंट जा रहा है वी आर हैविंग -3 बट हियर 6 एम्पियर इज कमिंग सो वी कैन टेक -3 + 6 दैट विल बी टोटल करंट into resistance. That resistance is 3 ohm. So you will get 3 into 6 that will be 6 into 3 that will be 3 into 3 sorry 3 into 3 that will be 9 volt. 3 that will be 9. If we are having this circuit, so if we are supposed to see here, why does it work? Why we can apply here superposition? If you can see here, if we are having this circuit, we can apply here KCL. If we are applying here KCL, you can see we are having the values by using the node analysis. If we are using here node analysis for this circuit, if we are using node analysis, we are having the node V1 and V2 and we can consider this as a reference node. So we can calculate for V1 and V2. We can see V1 is connected with this, V1 is connected with this, V1 is connected with this. So you will get 3 equations here. For V2, you will get these equations and these equations, 2 equations, because V2 is connected with V1 and V2 is connected with this current. So you will get for V1. V1 के लिए कैसे लेंगे? For R1 firstly take, for R2 secondly, and for R3 you will calculate because V1 is connected to 3 resistors. So for R1, V1 minus 0, V1 minus 0 upon R1. Here we are considering 0, but here we are having the supply voltage. So you can take V1 minus Vs minus 0 upon R1. So our equation will become V1 minus Vs upon R1 and that 0 will, we can, so here if you see for this R2, how will you get here? R2 upon V1. Here, if you are calculating the value of current for this R2, how will you get? V1 minus 0 because here also we are considering it is a reference. So यहाँ पे 0 आएगा. So V1 minus 0 upon R2. So your equation will become V1 minus Vs upon R1 plus V1 upon R2. If you are calculating for this R3, how will you get? V1 minus V2 upon R3. So I have written directly V1 minus V2 upon R3. Now, if you are calculating node analysis for V2, for node B, how will you get? If you see here, we are having the value of directly current. So there is no need to write V2 upon 0. That will be 0. But we are having the value here, IS. But it is incoming. So we can take it is as a negative. Now we can see V2. This B node is connected with A also. So we can calculate V2 minus V1 upon R3. Why I have taken here V2 positive and I have taken here V2 as a negative? Because for node 1, node A, when we are considering at that time we are supposed to consider voltage across that node will be positive. हम यहाँ से start करेंगे जब हम node A के लिए निकाल रहे हैं. That's why I am taken V1 as positive and V2 as negative. और जब मैं node B के लिए निकाल रही हूँ, ये second equation B के लिए, first equation node A के लिए. When we are deriving the equations for node B, at that time we are supposed to consider the voltage across that point as a positive. That's why I am taking here V2 as positive and V1 as a negative. So here, if we are writing equation in the form of matrix, you can write equations. If you are writing, you can write G1 plus G2 plus G3. If we are having 3 resistors, you can write that equations in this form also. So here, if we are supposed to use the Thevenin circuit, what we are saying, if we are having any complicated circuit, we can convert that complicated circuit into a simplified circuit where we will get only one resistance and one voltage source. So how we will calculate that Thevenin resistance? We can calculate Thevenin equivalent resistance. How? If we are having any complex circuit, at that time we can consider Just wait for a minute. See here. What we are saying, if we are having any complicated circuit, at that time we can convert that complicated circuit into a simplified circuit. So if we are having the circuit at that time, if that circuit is consist of lots of resistor, lots of voltage sources, lots of current sources that are the dependent, we can see here these are the dependent one. At that time we can use the Thevenin circuit, because our aim is here to replace that complicated circuit into a equivalent circuit where we will get the equivalent voltage. We are calling that voltage as a Thevenin voltage, and we will get here Thevenin resistance, or we can say it is a equivalent impedance, and that will be in series with the Thevenin voltage source. Or here we are saying that circuit as a Thevenin equivalent circuit. So here if you see, when we are supposed to find that complicated circuit into a simplified Thevenin equivalent circuit, at that time firstly, we can calculate the values of Thevenin equivalent resistors. At that time, we can consider temporarily all these impedances as a open circuit. We can see one example at that time we will get. So what we are saying here, we are saying that Thevenin voltage, that is nothing but voltage that will be across this point A and point B. So we can say this is the open circuit voltage. VOC is nothing but the open circuit voltage. So we can find RTS by using any method. You can use, if there are series resistance, you can take additions. If there are resistors that are in parallel, you can use 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 up to 1 upon R equivalent. You can use any method. So here, if we are having any complicated circuit, at that time, we can deactivate all independent sources, because here we are considering resistor, voltage sources and current sources which are dependent. We are converting that into a simplified circuit. So here, what we can say, we cannot convert that circuit into only Thevenin equivalent. We will be required here voltage source also, and that will be in series with this Thevenin equivalent resistors. So here we can deactivate all independent sources and we can calculate the values of Thevenin resistors. And if you see here, we can make the circuit as this. If we are having any circuit, what we are saying here, we can convert our Thevenin circuit into a Norton's. Here in Thevenin circuit we are converting complicated circuit into a simple circuit where we will get one voltage source that will be in series with the Thevenin equivalent circuit. In another language, we can convert that voltage source and into a current source, and the value of resistance that will be remain same, but that will be in parallel with this current source, and we are saying this network as a Norton's network. So Norton's और Thevenin में क्या चेंज है? Thevenin में हमें वोल्टेज और रेजिस्टेंस मिलता है, वो सर्किट ओपन होती है और वोल्टेज के साथ रेजिस्टर सीरीज में होता है, and we can convert that circuit into a current source. How? Current source will be in parallel with the resistor. That resistance will also like a equivalent Thevenin resistance that will be exactly same with the Thevenin equivalent resistance. But यहाँ पे सिर्फ सर्किट जो है वो पैरेलल है और यहाँ पे क्लोज सर्किट है. So here we can say we can convert voltage source into a current source by using the source transformation method, and when we are converting our Thevenin equivalent circuit into a current source where resistors will be in parallel with that current source, at that time we are saying that network as a Norton's network, and we can calculate the value of Thevenin resistance as VOC upon IS. V upon I, that will be equal to RTS. We are saying it is as a Ohm's law. If we are having this example and we are supposed to find the value of VOC and the RTS. If there is load, at that time we can take that load directly at our आंसर. जैसे तुम्हें आंसर मिलेगा एट दैट टाइम ये VOC RTH ज्वाइन करने के बाद RL तुम कनेक्ट कर सकते हो. इफ दे आर नॉट गिविंग एट दैट टाइम, there is no need to connect RL. You can consider this as a open circuit, because in Thevenin circuit we are considering that complicated circuit converting into a simplified, where we will get Thevenin equivalent voltage source and the Thevenin equivalent resistance. If there is RL, we can connect that RL as it is at the output. So here, when we are supposed to find VTH, at that time, we can consider this RL as an open circuit. So we are considering this as an open circuit. So here, you can see here, these 2 and 3 are in parallel because there is a node. ये नोड पे 3 रेजिस्टर कनेक्टेड है, so we can take these 2 are in parallel and these are in series with 6 ohm. So you will get the value of total resistance, you will get the value of total voltage, so you will get the value of voltage. So total voltage we are aware about. We are supposed to calculate VOC. VOC equal to total voltage into the resistors that we are supposed to find, across which we are supposed to find the voltage. करंट में क्या करते हैं, ये नहीं लेते हैं, उसके पैरेलल में जो रहता है वो लेते हैं. यदि हम यहाँ पे करंट डिवाइडर यूज करते रहे तो हम ये रजिस्टर नहीं कंसीडर करते न्यूमरेटर में, जो उसके साथ होता है, जो उसके पैरेलल में होता है वो कंसीडर करते हैं. बट हम यहाँ पे जो जिसके अक्रॉस का वोल्टेज निकालना है वो कंसीडर करेंगे न्यूमरेटर में, और डिनोमिनेटर करंट डिवाइडर रहो, वोल्टेज डिवाइडर रहो, दैट विल बी सेम. वी आर टेकिंग हियर एडिशन. सो फर्स्टली वी विल कैलकुलेट दिस 2 into 3. You can see here, when we are considering this as an open circuit AB, and when we are supposed to find VOC, at that time you can see here we are supposed to find the voltage which is flowing across, which will be across 3 ohm. So you can take 3 ohm in numerator and 3 plus 6 in denominator. So there will be question, why we have not taken 2 ohm, why we are considering only these 2, because we are calculating the value of voltage that will be the Thevenin voltage that will be across these 3 ohm, because we are considering this as a open circuit. तो ये 2 ohm consider करने की जरूरत नहीं है, that will be working as a wire. That's why we are considering only these 2, because हम यहाँ पे Thevenin यूज कर रहे हैं. Thevenin open circuit voltage draw करना है. At that time we are having the total voltage, we are having that resistance, we are having the parallel resistance, so we can calculate. You will get 3 ohm upon 6 ohm plus 3 into total voltage, that will be 9 volt. पांडुरंग, अभी 10 मिनट क्लास को बचा, अब क्या ज्वाइन किया तुमने क्लास को? ऑन जब टाइम होता है तभी यू गाइज आर सपोज टू ज्वाइन द क्लास ऑन टाइम ना. आधा लेक्चर मिस कर दिया. Okay, now we are supposed to find RTH. At that time, if there is a voltage source, we can consider this voltage source as a short circuit, and if there is a current source, we can consider this as a open circuit. This rule will be for Thevenin and also for the Norton. So here, when we are considering this voltage source as a open source, we are supposed to find the RTH. We are supposed to find RTH. So here you can see these 6 ohm and 3 ohm are in parallel. We are supposed to start from this way, because here we are supposed to find the RTH जो A और B के बीच में है. So here you can consider 6 and 3 in parallel, and these are in series with 2 ohm. So you will get 6 into 3 plus 6 plus 3, 18 plus 3, that will be 2. So 18 plus, sorry, 6 plus 3, that 6 into 3, that will be 18, plus 9, that will be 2. So you will get here value as 2 plus 2, that will be 4 ohm. You can calculate RTH as 3 and 6 in parallel, so 3 into 6 upon 3 plus 6 plus 2, so you will get 2 plus 2, that will be 4 ohm. So now you can convert, you are having the value of VOC, you are having the value of RTH, you are having the value of RM. You can take as it is, and you will get our circuit as, circuit will become like this, and here you can write VTH equal to 3 volt, RL as it is, and RTH you can write as a 4 ohm. I have written here, you can see here, this is the Thevenin equivalent circuit. 3 volt 4 ohm RL. Now, maximum power transfer theorem. Maximum power transfer theorem states that maximum power will transfer to the load if the value of RTH equal to the RL. मतलब load resistance का value जो है we are supposed to check is it equivalent with RTH or not. जैसे अभी थिवेनिन देखा है, exactly procedure we will do in Norton's. What will be the difference? Here we can convert Thevenin circuit into Norton's, or we can solve directly for the Norton's. How we can solve? If we are having the circuit, we can consider that, sorry, if we are having any complicated circuit, at that time we can convert that complicated circuit into a simplified circuit where we will get the value of shunt current and the value of Thevenin resistance that will be in parallel. ये करंट के साथ यहाँ वोल्टेज की जगह करंट रहेगा और यहाँ रेजिस्टर पैरेलल में रहेगा. And if there is a load, you can consider as it is at the output. So maximum power transfer theorem क्या बोलता है? If the value of RTH equal to RL, at that time maximum power will transfer to the load resistor. And we know how to calculate power. Power is nothing but V into I. Or you can write I, V into I को तुम क्या लिख सकते हो? V को तुम IR लिख सकते हो. So I into IR. So you can write I square RL. So here you will get power load as IL square RL. So for given circuit, we will get the maximum power if the value of RTH equal to RL. So here we can convert our circuit into a Thevenin circuit. So you will get the value of RTH. You can compare that value with RL. If both are same, you can say maximum power will transfer to the load. And how will you get the equations for power? We know power is equal to V into I. But we know I is nothing but, if we are having VTH, we can take VTH according to Ohm's law. I equal to V by total voltage VTH upon total resistance RTH plus I. If we are calculating power, you can write VTH square into RL upon RTH plus RL square. You can solve the maximum value of power. And if we are considering dPL upon dRL equal to 0, you will get these equations. We can see remaining in the next session. We can solve one example also on Norton's and maximum in next session. Because we are having only 1 minute, we will not finish. Now I am taking your attendance. Okay. You guys can leave now. Thank you.